Hey guys, welcome back. In this video, I want to talk about the MIMO channel estimation. Till now, in this series, we have spoken about the channel estimation, mainly considering the CISO case. So I will just give the glimpse of it. In case of CISO, at the transmitter and the receiver, let's say we have only one antenna. So if you have one antenna, then we will have one OFDM grid. Okay, I'm just going to write one OFDM grid here, which means that this OFDM grid is of one slot worth, and it has got 1, 2, 3 up to 14 symbols. Okay, in one of the symbols, let's say we are transmitting the reference signal, or what we call it as DMRS. Okay, so across the subcarriers, y-axis will represent the subcarriers, right? So across the subcarriers, let's say this is first subcarrier and this is a third subcarrier, like that. In the alternate subcarriers, the DMRS sequence are present. Okay, DMRS samples are present. So let's say the odd subcarriers are occupied and even subcarriers are vacant. This is as per the GPP, the spec. So here in this particular video, we will talk about two things. One is how is DMRS allocation done, considering the various scenarios, okay, for MIMO and for CISO, things like that. And the second one is mainly we will talk about how to perform the channel estimation once this the DMRS locations are given and the receiver. Okay, so this is the DMRS locations for one port. Um, now if we start writing the equations of the receiver, at the first subcarrier, we can say that the y1 is equal to h1 x1 plus n1. Okay, then at second subcarrier means here we have the third subcarrier location, y is equal to this one. So how are we doing the channel estimation? Basically, you apply the least square estimator in a simplified form. It is as good as applying x1 conjugate over here, considering the DMRS sequence um, design. So then, if you just perform x1 conjugate, then you will get h1 add, which is required for us, and some error, and we know how to reduce this error in earlier videos. So basically, this equation has got only one unknown, and for which we have x1 known to us. So this is sufficient to predict or estimate this unknown quantity h1. Okay. Now coming to MIMO. So in case of MIMO, how is the DMRS allocations done as per HPP? That is the question, right? So before that, let us say I have got a transmitter where I have got two antennas, and I have got receiver and I have got two antennas, and we have H11, H22 and cross terms. Let's say this is H12 and H21. Um, I have considered this as antenna 1 and this at the antenna 2. This is the DMRS symbol. Okay, in one particular slot. If I go back, I will be only considering this one from now onwards. Okay, in this particular slot. So in this particular slot, let's say this is a DMRS symbol location. Okay, and even at antenna 2, we will have a different OFDM grid, and there also we will have a DMRS symbol. Let's say if I transmit DMRS something like this, x1 x1 x2 x2. Okay, the same sequence is transmitted across antenna 1 and antenna 2. What is going to happen? So first what I will do, across the first subcarrier, I will write the equation at the receiver. So that is y1 is equal to, because let me write here, okay, x1 is transmitted, x1 is transmitted, first subcarrier, right? So then h11 x1 plus h12 x1. Okay, similarly y2 also we can write it. I will basically get this equation. Okay, so this equation can be written in a matrix form or vector form, something like this. So it is pretty much straightforward. Okay, I have not written the noise, but we can write a noise bar as well. Now at third subcarrier, Okay, and this is M1. So similarly I can write this one M2. Okay, so if I try to stack it up, okay, this will become my Z1, this will become my Z2. I'm going to stack it in this way. Okay, so let me rub it, and okay, this is Z1 and this is Z2. Now it will become something like this. Okay, then noise matrix. Now if you see, I have four unknowns, I have these two quantities. This should be sufficient to estimate this channel matrix H. Okay, so I right now consider 2 cross 2, but the thing is that, as I was mentioning, we need to have a certain property of this matrix, otherwise we'll not be in a position to estimate it. So let's, for that, let me take a least square solution. So for this, what would be the least square solution? So I will write it here. So I have now y is equal to hx plus n. All are matrix, okay? Matrix 2 cross 2. So my solution is that I need to multiply y with to y, I need to multiply this quantity. Then I will get my h plus n into this quantity. I will say w. Okay, so n into w. I got my h. Okay, with some error over here. But x into x formation, what is it? If I go back my x, it is how it looks like. It will be like x1 x2 sorry, x2 x2. This is mod of x1 square plus mod of x2 square. So let's say I will call this as just a. Then even all four terms I will get a. If you see this matrix is not invertible, and that's why we will not be in a position to perform the channel estimation if we have such a kind of criteria. Definitely we need say, some different kind of criteria, and that is when GPP defines a different allocation of DMRS when we have you know um, MIMO, or when we have two layers, when we need to transmit data on antenna 1 and antenna 2. Okay, so what is that? So I'm just going to write it over here. So the first thing is that DMRS is allocated on antenna 1, something like this. Okay, so but whereas on antenna 2 it is allocated on different locations which is orthogonal to this one. Okay, so here we have odd subcarriers, and here we have even subcarriers located. That is why even if you see here, in the CISO case as well, there was one subcarrier left vacant in between. That subcarrier was useful in case of MIMO. Okay, now let us see how to do channel estimation over here. um, so across a subcarrier um, 1, okay, this is a subcarrier 1. What are my equations? Y1 is equal to, I will get h11 x1 plus, okay, let me write that here for clarity. Okay, so I have these terms, cross terms. So in the first subcarrier I am transmitting here 0, I am transmitting, right? So in here I have transmitted 0. So this is y1 y2, so h11 h22, h12 h21. So then what do I get? H11 I have x1, right? And then plus here I will have h12 dot 0 n1. So I hope you are getting these equations. Please try to go through. How can I write in matrix form? So y bar is equal to h1 bar x1 plus n1 bar, I will say. Okay. Basically, I would say h11 h21 x1 plus n bar y bar. Okay, this is for subcarrier. Okay, but I want to basically represent because we are dealing with 2 cross 2 MIMO, right? Okay, I want to represent in the matrix form. So I want to take third sorry, second subcarrier, because here in the second subcarrier itself we're going to transmit in the second antenna. So here definitely not the third subcarrier, we need to take the second subcarrier. So okay, if I take second subcarrier, okay, what are my equations? So I will say Z1. Okay, so in this case what happens, this is actually 0, but whereas this is x1, right? So how are things looking like? So now this will become h11.0 plus h12, x1 plus n1, z2 is equal to h21.0 plus h22, x1 plus n2, right? So basically, if I try to combine, okay, which means y1, y2, z1, z2, which is 2 cross 2. If I try to combine, what I will get is h11, h21, h12, h22. So then I will get, what do I get? So then I can write this in something like this: x1 0, 0, x1, right? So if you try to write it in equation form, definitely you will get back this particular equations, all four of these equations. So you can try out that, but this is how you will get it. Now you can clearly see that it has got some property, that is the column of this is orthogonal to the column of this, right? And even this matrix is invertible. Here if you can perform least squares, right? You can easily perform least square. So you can say h into x, right? So just you can say h Hermitian. So to this y, if you multiply h Hermitian, then this is error. So these two quantity, what does it become? So it just becomes identity h plus some error. Okay, so you got your H matrix, 2 plus 2 H matrix, and now I hope you got how to perform the chance estimation in case of MIMO. Okay, so there are a few more combinations that are specified in the 3GPP to perform the chance estimation, that we will come up in the next video. But for now, I think you got the clarity on how to perform the chance estimation, and even you got the clarity on how the DMRS allocated as per 3GPP to favor the chance estimation and the receiver. So with this, I would like to wind up the video. If you're looking for more videos, please do subscribe to the channel. Thank you very much. Have a great day. Bye bye.